Hello students, this is lesson U1A05c. I can prove angle congruence by using complementary, supplementary, or vertical angle theorems. In this lesson, we are going to be using the following ideas, the following facts. So the first one being, what is defined as a linear pair? So the definition of a linear pair is we have two angles that are adjacent to one another, and the two of them form a straight line. If we recognize this to be true, then this is in fact a linear pair. So again, two angles adjacent to one another forming a straight line. Well, what happens as a result of this? Two angles that are adjacent to one another forming a straight line will end up with this concept. Two angles that are adjacent to one another are indeed supplementary. Linear pairs are supplementary. This idea here comes in super handy, especially when it comes to solving for angles to be congruent. If you recognize that that you have two pairs of angles are supplementary, and one of those pairs, happens to be congruent to one another, I'm just going to ask you to pause the video and to convince yourself why this makes sense. So having thought about this a little bit, let's just take a quick glance at this. Algebraically, this should make sense. If we have in both of these diagrams here, I have angle A, and angle A A, of course, is going to equal to angle A. And if angle A and B are supplementary, which I am telling you right here, and angle A and C are also supplementary, which I'm telling you right there, then it is a logical conclusion that you can make. That is, angle B will be the same as angle C. And without having to go through the algebraic process of simplifying, subtracting, and isolating, we can actually just declare that certain angles are going to be congruent based on the fact that supplements of congruent angles are in fact congruent. And again, this concept here is a theorem because we can go through the algebra process of showing why angle B is going to be congruent to angle C. And if you need convincing, please pause the video and go through that on your own. But we're going to be using this in two examples in a moment. And of course, this concept here, vertical angles are congruent. So anytime you have two lines intersecting, we're going to have two pairs of congruent angles. In this case, angle A and angle B are going to be congruent. Angle C and angle D are congruent. So let's take a look. All right, so first example. I have three lines, two of which are intersected by a common line, L3. So what's happening here is I'm telling you that angle A is congruent to angle G. So I'm going to ask you to pause the video for a moment and see if you can come up with a logical reasoning as to why angle E will be congruent to angle C. Now that you had some time to think about this, angle A congruent to angle G, I'm just going to draw all over this, recognizing that angle A is congruent to angle G, right? And we're trying to prove that angle E is congruent to angle C. So wait a minute, angle A is also congruent to angle C, and angle G is also congruent to angle E. So all the angles, that are highlighted in pink, therefore, must be equal. So hence, angle E must be congruent to angle C. So we're going to try to now place that interpretation on a sheet of paper. And how are we going to do this? Well, step 2 here, what's going to happen is, again, recognizing that angle A is going to be congruent to angle E. And this is true for what reason? Oh yeah, it's vertical angles. Vertical angles are congruent. Similarly, angle G and angle E, I'm sorry, I miswrote. It should be angle A and angle C are congruent. I miswrote. And angle G is congruent to angle E. And again, for the same reason, we have vertical angles present. All right, so we're almost there. Our goal here is to show that angle E is congruent to angle C. So if I perform a series of substitution, we're essentially done. So isn't angle A, so in the very first statement here, we recognize that A is congruent to G. We also recognize that A is congruent to C. And we also recognize that G is congruent to E. We can perform a series of substitution and say angle E, or angle C, is congruent to angle E, because I'm substituting 2 and 3 into line 1. And based on the symmetric property, because I need to write it in the same exact manner in which the what I'm trying to prove has to be written in, I'm just going to flip that around using the symmetric property. Angle E is going to be congruent to angle C because of the symmetric property. All right, let's take a look at the second example. So I have angle A is congruent to angle E. And what I'm trying to do, again, I have 3 lines, 2 of which is intersected by angle 2. I'm sorry, 2 of which is intersected by line 3. Okay, L1 and L2 is intersected by line 3. And you're told that angle A is congruent to angle E. Angle A is congruent to angle E. All right, so now what we're trying to do is we're trying to show that angle E is congruent to D. E is congruent to D. Well, isn't A congruent to D because of vertical angles? And if A is congruent to D and if A is congruent to E, therefore we can make that logical conclusion that E must be the same as D. So, wait a minute. We know that angle A is congruent to angle D because the vertical angles are congruent. And if A is congruent to E and A is congruent to D, we can then logically conclude that angle E is congruent to angle D because of substitution. Simple enough. This is substituting line 2 into line 3. All right, so the next part here, we're trying to prove that angle E is congruent to angle F. C is congruent to angle F. We're trying to show that C here is congruent to angle F. All right, so do you notice that A and C is a linear pair? And do you also recognize that E and F is also a linear pair? And what do we know about linear pairs? We know that linear pairs are supplementary, right? We know that they're supplementary, and we also know that A is congruent to E. So therefore, we can use which of these theorems or definitions to prove C is congruent to F. Again, pause the video and make a conjecture. So if you thought that we can use this fact here, then you're absolutely right. We are going to be using supplements of congruent angles are congruent. So recognizing that angle A and C, so we recognize that angle A plus angle C is equal to 180. And we also recognize that angle E and angle F is equal to 180. This is because of linear pairs are supplementary. So therefore, the second statement is also true, that the linear pair is supplementary. All right, so recognizing this, we know that angle A is congruent to angle E. And both of these are in these statements here. C and F are supplements of those congruent angles. Again, one more time. Angle C and angle F are supplements of those congruent angles. Those congruent angles being angle A and angle E. So because of this fact, we can then declare in line 6 that angle C is congruent to angle F. And the reason for that is supplements of congruent angles are congruent. There you go.